Yeah, ladies and gentlemen, I have been silent for a longer time, was busy with other things, and here I'm back again with some remarks on basics of business administration. And it's really the basics of the basics only, so don't be disappointed if we stay on the surface. My idea is just to give you a very basic understanding of the elementary things. Now, what's investment theory or investment decisions confronted or as an opposite to financial decisions? Um, where finance focuses on the question where the money comes from, investment is just the question where your money should go to. So, if you have several opportunities to invest, which one do you choose? How can you make a reasonable choice instead of just throwing the dice? So, there are two basic questions. If you invest, is that profitable or not? And the second thing is, if you have several opportunities, which one is better than the other? So, here there are two fundamentally different approaches. The one is the rather simple one, and the next one is the more complicated one with more calculations. And you can also call them the static criteria, where you just make some average calculations. You just calculate a profit or an average profit or a profit per money invested or so. And all these static criteria have one thing in common. You leave the time aspect completely out of consideration. So you don't ask if a profit comes in 10 years or tomorrow. This is naturally in real life a big difference. And the dynamic criteria for decision try to take that into account, and there is a good model how one can make money at different points of time effectively comparable so that it stands critique when you confront your ideas with the real world. But let's begin with the static criteria. First and most important or most simple criterion is, will we make profit or not? Now, profit is defined as revenue minus cost, you know that, or you can also say revenue minus expense, however you define it, but it's always the net amount which results from your activities. Well, and naturally, if you make a loss and can even foresee that, not a good idea to invest there your money. The problem with prognosticizing the profit before you decide is naturally prognosis refers to the future, and the future is not certain, so you probably have to take some likelihoods into account. Not such a primitive thing is return on investment. That would be profit divided by the capital invested. So there you get a percentage as a result, and now that percentage figure allows you to compare your investment possibility or your investment chance with other chances where you can also find a rentability. So a percentage number. For example, if your calculation shows you that the return on investment of your project will probably be only 0.1%, then it's probably better to place your money in a bank account where you get an interest rate of 0.5%. On the other hand, the return on investment percentage could give you some valuable information. If you expect something between 20 and 10%, and now you want to finance the necessary capital by credit, and the bank charges you 4%, then you can reasonably expect that if you earn 20, in the worst case 10% from the investment, the bank claims 4%, that you are relatively safe and will end up with a profit even when you have to take up a credit to finance your investment. Return on sales, also an interesting figure. That is profit divided by sales. That shows you which percentage of the sales, and sales means revenue from sales, stays as net profit in your hands at the end. The break-even period is also an interesting thing. It's a figure which is measured in years. For example, 2.5 years is the break-even period. That is that period of time which you need to recover your initial investment from the difference from the prices and the variable cost of the things you sell. So when you are out of the risk, when you have recovered your initial money, and so when you now enter the profit zone. That is an interesting information, because a break-even point of 2 years is different from a break-even point in 100 years. Under the prognosis aspect again, I can probably form a relatively concrete and precise idea of what is going to happen during the next 2 years. Now, when it comes out, I will have to wait 50 years until my initial investment pays off and is recovered and the profit zone begins. Well, in 50 years, many things can happen, so there is a high risk combined with that project. So the break-even period gives you some information on kind of risk. It depends on how safe or how reliable are your expectations for the future. The amortization period, by the way, is just the same as the break-even period. Now, let's come back to profit. Normally, you would say, well, profit, clear criterion. I can earn 100,000 there and 500,000 there, so I take the 500,000 project. That's plain and simple. Now, on the other hand, no. Because you overlook some things there. First, it might be that you can get the 100,000 profit in a second, just now. On the other hand, it can be that the 500,000 can only be made after a waiting period of, let's say, 90 years. And now if I pose the question again, what do you prefer? The project with a profit of 100,000 or a project with a profit of 500,000 after 90 years only? Then you see, higher profit is project B, but that's after the end of my life. So is that really a good idea? So I would then prefer project number A. Also, the two projects might be not comparable under the aspect of capital which you need to invest and the work which you have to do. Might be that project A is investing €2 and getting 100,000. I can only think of the lottery just now. There is no other realistic project like that. And on the other hand, might be with heavy work and with an enormous amount of capital and risk, you could obtain the 500,000. So it's not a simple choice if you take into consideration that the projects will have differences. Similar problems will show up if you look to the annual profit. So if you say, well, let's say project 1 takes a duration of 5 years, project 2 a duration of 10 years, then if you can make 1 million in project A, that would be, what did I say, 10 years? That would be 100,000 per year. And something else might be a different figure, but for a different amount of years. Here in the slides, I show you annual profit 100,000 for 2 years, or annual profit a bit lower, 90,000, but guaranteed for 10 years. What do you prefer, ladies and gentlemen? And the answer is, well, you will naturally ask, what can I do after the 2 years? Will there be emptiness, laziness, nothing to do, no investment alternative? Or can I take the 100,000 for 2 years and then have a succeeding project where I also get rich every year? Or am I bound then to wait for years to come without any opportunity to let my money work? So it's not easy. So annual profit, not a perfect criterion. Sometimes you don't have equal annual profit, so you would artificially have to transform the expected profits during the period where your project is executed, however you call it. Um, so you would have first to transform the profits of every year into an average profit to make it comparable. Then again, you have that problem. If the average profit in the one project is 500,000 and the average profit in the other project is 400,000, if the periods of years are different, then it's no easy decision. So then you need additional information, or you can't make a reasonable decision under any circumstances. Good. Something else, if you try to get a percentage figure, the return on investment, then you create a ratio between the profit coming from the project and the capital needed to invest. So a percentage like your interest rate in a bank account, and that makes the rentability comparable. Now, again, the problem. It's not always comparable. What do you prefer? 10% on 2 million invested, or 50% on €1 invested? Well, okay, 50% sounds nice, but in my world that would be just on €1 invested, so 50 cents. Would it be preferable, or wouldn't it be preferable to invest 2 million with only 10%? That would be 200,000. So this is again the basic question. And it might even be that the amount of capital needed to invest changes over time. For example, that you can recover a bit of your initial investments over time. Then how you can solve this. Here, by the way, traditional approaches, so the static approaches, usually work with a simplified approach. They just say you have a certain amount of capital which you need at first. Let's say 100. You have a certain amount of capital which still is involved or bound by the investment at the end. Let's say 10. So you have a constant decrease of capital invested from first 100 to later only 10 at the end. For example, you buy a car for a price of, let's say, 20,000. You are a taxi driver, you are going to use that car to produce your profit. And after the end of the useful life of that car, you prognosticate you will be able to sell it for 2,000 of final value. So the capital invested in your taxi is first 20,000, and then via recovering the money invested via depreciations, at the end you still only have 2,000 bound in your or involved in your investment. So the capital invested constantly goes down over time, and the traditional approach is just, if you look to that, if you really can assume that the decrease of capital needed is constant, then you can make an average calculation. The decrease here in my first example would be 100. Remember, invested first, 10 left over at the end. So you have a decrease of 90. And now you could say the average of the 90, that is the amount which is invested in the average. So 45. So you would have 10 at the end, plus the 45 in the average of the capital which decreases over time. So 55 would be your average investment over time. Yeah. So now you could say, if the capital invested decreases over time, I could make a calculation and say 55, or the average capital invested calculated according to this idea here, that would be the one on which I use to calculate my average rentability, my return on investment. Now the return on investment again has a big issue, a big problem, because if you calculate with that, or if you calculate with average annual profit, which is underlying the return on investment idea, then you have one big problem. Imagine one project has the following cash flows: 5 in the first year, 4 next year, 3 in year 3, 2, and then 1. So a big amount of money comes first and then it drops down constantly. And the other one is exactly the other way around. €1 first, €2 next year, 3, 4, 5, and then finish. The average annual profit is the same. The rentability, based on the average annual profit and the average capital invested, will be the same. But naturally, the two projects are completely different in their attractivity. The blue one is combined with a far lower risk. Big amounts of money come immediately. I can withdraw them and reinvest them. And the risk of failure is far lower because the big amounts, which I need to repay my investments or so, come in the beginning. Whereas in the second project, I have to wait for that money. So project A, the blue one, is definitively more desirable on the economic aspects. But if we use the static criteria, we will not find that out. So what can we do against this? How can we take these time aspects into consideration? And that is the dynamic approach for decision criteria. That's usually called investment calculations. And here they just look for a reasonable answer to the question, how can future money be effectively transformed compared with present day money? And the answer is relatively simple if you reformulate the question a bit. How much money can I get now from a bank if I can guarantee that I will have in X years, for example in 1 year, an amount of 50 euro. So 1,050 euro. Well, now just think about that. If you get revenue of 1,050 euro in 1 year, you can now go to a bank and take a bank loan of X euros or dollars today. For that bank loan, you will have to pay interest to the bank. And now, if you choose that bank loan, exactly identical to the amount which paid back in 1 year plus the interest which is due to the bank, then you have effectively transformed a cash flow in 1 year into a cash flow of today. And the nice thing is, if that 1,050 euro is certain, this will work in reality. If there are banks, if you are worthy of a credit, and you are if the cash flow in 1 year is certain, then you get that money. And so this is not a theoretical approach. As long as the interest rate which you take into account for that calculation is a realistic one, which you could get from a bank for a credit, then indeed 1,050 euro in a year are 1,000 euro effectively available of today. You just could go to a bank, tell them, here, in 1 year I get that money, here are the proofs, I can make sure that I will have it, give me a certain amount now, for example, give me 1,000 now. Then the bank will give it to you, and they don't even ask for what you spend that money. Because if the paying back of the interest and the loan amount is certain, no bank will ever care about where you waste your money for. So this is the important thing you must understand, the interest which you take into consideration in that, which you take to calculate here, must be a realistic one. As long if that is the interest which you would really pay for a bank, this is a very realistic approach. It would work. Now, if you begin and dream of interest rates, for example, well, for my investments or for my credits, I would like to get somebody who gives me a credit for 3%, although everybody has to pay 5%. Or it should be fair that I only pay 5%, but others ask 8% from me. The only realistic interest rate would be 8%. As long as you stick to reality concerning the interest rate which you have to pay, everything's fine. When you begin to deviate from that and say, oh, for example, I want for my capital a higher interest rate, then you end up in dreams and castles in the clouds. That sometimes happens when people try to use that approach for their own models. They sometimes begin with dreaming about interest rates, but then they deviate from realities. Now, we did this now with future revenue. On the other hand, you can also transform future expense into expense of today, make it comparable. You can just simply reformulate the question again. If I have to pay in 1 year 1,050 euro, how much money do I need to pay now or place now into a bank account so that when after a year or 2 years or 3 years, whenever the expense is going to be paid, I just can take the money plus the interest which accumulated in that bank account and pay that payment obligation. So you can effectively get rid of an expense in the future by an expense of today. The question is simply, how much money do I need to put aside into a bank account which brings interest now, so that after a while on that bank account there will be in year 3 or 4 exactly the amount which I need to cover that expense. Again, the important thing is here, the interest rate by which you calculate that must be a realistic one. It must be an interest rate which you can obtain in a bank. You cannot say, well, it's a high-risk investment which I do. I dream of 8% interest rate. If you can only get 0.1 in a bank account or in a safe investment over that period of time. So as long as you stick to real world data when it comes to the interest rate, again, that model which transforms the future expense into an amount of today is absolutely realistic. That is economic truth then. Now, if you deviate and invent market data which are not there in the market, then everything is bad. And here, even when I mentioned that, the program begins to run wild and protest, and you saw that the slides went mad. Now, just to illustrate that again, future expense. Imagine you have to pay 2,100 in 1 year, and now the question is, how much do I have to place into a bank account today? Imagine, for example, 5% would be the interest rate. Then an easy calculation, put 2,000 aside in a bank account with 5%. I know there have been times that 5% were obtainable when I was very, very young, by the way. Then 2,000 put aside today in a bank account which brings interest of 5% would be entirely sufficient to cover an expense, a payment obligation which is due in 1 year of 2,100. So you could place 2,000 aside now and forget about that obligation. You already covered it completely. This is safe and sound now. You don't need to bother about it anymore. You just have to take to that bank account in a year and everything. So now, again, an example. First, look to future income of 1050. Interest rate shall be 5%. So you can go to a bank and say, give me a credit of 1,000 now, and 5% will be interest. That's a 50, and that is why you can pay back that loan exactly after 1 year with 1,050 euros. So 1,050 1 year gives you available money of 1,000 now. If you place that in a formula or express that in a formula, it's very, very simple. If you see an amount of P0, for example, the 1,000, in a bank account today or a loan today, depend on whatever you want to have, a positive or negative amount, you will have, after 1 year, an amount of P01. So that's the initial amount, P0, times 100% plus I, the interest rate. And now, if the future value is given in 1 year, 1,050, then you just end up with the formula here. The P0 is P01 divided by 1 plus interest rate. In our case, that would be P0, the necessary amount, or not the necessary amount, the present value of the future. 1,050 euro is 1,050 divided by 100% plus 5%, so by 105%. And indeed, if you calculate 1050 divided by 1.05, you end up with 1,000 euro. Nothing could be more easy. You could even extend this to more than 1 year. If you have in 2 years the 1,050, then 1 year before you need 1,000. So 1 year before, you don't need, you would get from a bank 1,000. Now you need it 1 year earlier, so you would have to pay interest for 2 years. And because you don't pay that interest in the meantime, it would just pile up. And so you have to deduct that again. So 1,000 divided again by 105% leads us to a present day amount of 952.58. So that would be the present value of 1,050 years, 2 years before. No problem, just a simple thing. You can make the test. If you borrow 952.58 from a bank now, you have first to pay 5% interest, 47.61 or 62. You end up with 1,000, which you owe to the bank after 1 year. Now you don't pay it back. So again, 5% interest come on top. That's the 50 euros. So after 2 years, you owe the bank 1,050 euro. That's exactly what you get as cash flow in 2 years. So you can pay it back. You don't need to worry about what happens in 2 years. Every obligation there is covered by the future revenue. So you don't need to worry. You could borrow that money now without any risk and then spend it. Okay. So that's the formula for the present value of the payment. To repeat that again, after n years, the value of a payment in Tn, that's year n, so let's say year 2 in our former example, divided by 1 plus I to the power of n. So n times divided by that percentage. In our example, 1,050 euro divided 2 times by 105%, so by 1.05. You can also calculate the value of a payment after a certain while, compound value, or far better is the term future value after or in a future year Tn. That's the same. You place a certain amount now, PTO, into a bank account, and then you let that money alone, and the interest comes year after year on top. So after year one, you have 105% in our example on the bank account. That is then taken by 105% another year, and so you end up with that formula. After n years, PTO will be taken by 1 plus I to the power of n, and then you end up with the value after n years. Very plain and simple. Now, when you believe in that approach, and you should, then you can have a very realistic approach, view on the value of a possible investment project, because if you can regard the future payments or cash flows as certain, then you can transform all these future cash flows by that investment calculation model into a present value. You can replace a future payment in T04 by its present value, and then you can just add all these payments up, and then you could directly see how much money you could withdraw from a bank today. So irrespective of the money which you need to invest, you get the direct answer to what you can obtain from that investment. So imagine this would be the prognosticized cash flows in the future. 20,000 would be necessary initial investment now, 10,000 come after 1 year, 13,000, then 12, then 10 afterwards. These figures are absolutely randomly invented by me, complete brainless ideas. Just I took them from nowhere, just an arbitrary example. But how could we find out if that is profitable? Let's imagine the interest rate in the market which we would have to pay for a credit from a bank would be 6% in all these years. Good. Now 20,000 which we have to pay today is 20,000 today. That's plain and simple. Good. Now 10,000 which we get in 1 year, that could be transformed by a bank credit into 9,433.96. 13,000 after 2 years would be identical to 13,000 divided by 106%, and again divided by 106%. Surprise result is 11,569.95. 12,000 after 3 years. You could go, if you can prove you get it, you could go to a bank, say, okay, give me a credit, which will be paid back by that money in 3 years. Then you get 12,000 divided by 106% by 106%, and again by 106%, and it comes out €10,075.43. 10,000 in T4 are equal to, same idea, same formula, same basic logic, to 7,920.93. Now, if we add that up, is for our project you need to spend 20,000 immediately, and the present value of all future cash flows would be equivalent to what is listed up here. And if you add it up, surprise, a surplus of 19,027. So over these 4 years, you make a total profit now, which could be withdrawn now, of 19,000. Congratulations. Now you could even answer other questions. For example, not everybody wants to withdraw 19,000 at the beginning and then in the future live from nothing. So sometimes people ask, which identical amount can I withdraw over each year of the project? So they ask for an annuity, and mathematicians have found a nice formula how you can transform a given amount of today into a series of constant payments during n years. That's called the annuity factor or annuity formula. You could also transform a series of constant expected annual payments into a present value. That's just the other way around then. So the present value of an annuity would that be. If you want to transform a given series of constant annual payments, by the way, annual with only one n, sorry, I can't amend that yet now, you know it's wrong. So a complicated formula, nobody can remember that properly. Oh. And so 1 plus I to the power of n minus 1 divided by 1 plus I to the power of n times I. That is the factor, or that is what comes out if a constant annual payment of €1 is transformed into its present value. If now you want to transform a given figure now into constant annual payments over n years, that's just the other way around. So that's just the reciprocal value of that formula. And so we'll just have to exchange the denominator and what the other thing in mathematics. You know what I mean. Good. Here again an example. The annual payment, now evidently there my brain came back, and annual is now written with 2n. The annual payment of €1,000 during 5 years shall be transformed into a single present value, the interest rate being 10%. So you need the present value of that, the appropriate factor, and here's the nice formula. Then I filled in everything, and the factor came out as 3.78 and some other nice ciphers. That taken by the multiplied by the 10,000, and you ended up with 37,801. So that means you could, if you can, certainly and with safety expect 10,000 5 years each year. Then you could go now to a bank, give them the data, say, okay, 10% interest rate, that's my credit interest rate, I accept that. Give me a credit. Then they would give you 37,801.28 cents here cash on your hands, and you can spend it however you like if the future payments from that annuity go to them. It would be exactly sufficient to pay off credit and interest. On the other hand, if you have €10,000 now, sometimes you want to say, how long can I live from that? Or, imagine you saved up in a bank account 10,000 and you want to use that to finance your old age, and now you say, when I retire, my life expectancy is still, let's say, 5 years. I hope it's not. I hope it's 35 or 42. But naturally, it would be hard to calculate that. So we just imagine you want to have a constant flow of cash during the next 5 years. And now the annuity factor is the reciprocal factor of that present value factor of the constant flow of cash flow. So 1 divided by the 3.709, so 0.26454, 1 and some other figures, and that means 10,000 now are equivalent to 2,645. Wrong comma. Here the comma should be between the 4 and the 5. So 2,644, that would mean if you can place 10,000 in a bank account now at an interest rate of 10%, and after 1 year you withdraw 2,644 euro, then the remaining amount stays in the bank account, brings interest again, and 1 year later you withdraw again 2,644. Then your bank account naturally drops a bit down, and then 10% on the remaining amount comes again on top as interest. And after year 3, you withdraw again that amount, and after 5 years, your bank account will be absolutely at zero and exactly at zero. That is the idea of that annuity. Good. You can even invent or look to another criterion, which is also interesting. You could say we have a given amount of cash flows in the future at given point of time. And now, how high can the interest rate for credits go up in a bank before that project stops to be profitable? That is a kind of estimating the rentability of an investment project. Because imagine if the return on investment from a project is 10%, and the bank charges you 9% for credit, you still make a profit. Now, if the bank increases to 9.5, your profit goes down, and then you see the higher the credit interest rate which a bank charges you, the less profitable gets your investment for you. For example, if the return on investment, now stated criterion K, but if it brings 10% and the bank charges you 11, then you will not undertake that investment, at least not with borrowed money. And so one could say the point where the interest payments get higher than the profit you can make, that is the point where you stop to invest. And on the other hand, you could also say, and that's the approach here, the point where the credit interest costs eat up all the money which you earn, all the surplus which you have. That is evidently the point of rentability of that project. That's called the internal interest rate. So there you just try out where a present value which is positive becomes zero or a loss. So let's just try out our 6% in my profitable project here. With 6%, that was very profitable. Now we could try out what happens if 20% interest rate, and surprise, then the present values of the cash flows change. They go down because if you have to pay more for the interest, then you can withdraw less nowadays. And here is at 20%, so 9,000 left over. So much. Evidently, we could try out a higher interest rate, 30%. Surprise. 4,300 and some are still left over. 35, still a positive one. So 40. Higher than 40%. There I lost my motivation completely to go on and calculate that, because I already had that impression, okay, 40% profitability, 40% rentability, that is probably some mafia investment somewhere where nobody expects that, or in a branch, in a sector of economy which is entirely new, and so can have a very, very high return on investment because you are the very first and there is no competitor. So our project, which I invented here, was extremely profitable. I don't know if I should say. It's a shame, or if we should be proud, or at least in our imagination, we have highly profitable ideas. Now, the whole thing which I showed you here is just the basics of all investment calculations. Investment mathematics, or sometimes also called financial mathematics, deal with these approaches and these problems much more deeply. And they develop formula for, or they adapt these formula for all specific situations. And for example, what changes if the interest which you get in a bank account must be taxed, or what changes if cash flows which you pay out can be deducted as business expenses, or interest payment to the bank can be deducted as business expenses. What if the interest or rates are different during the years, and so on? You can make the models more and more realistic and more complicated, but it's always the basic idea which you should have grasped. You can, in real life, transform future expense, future revenue into expense and revenue of today by a realistic approach if you develop your model in a realistic way. And that's the basic and final message which you need to know. And naturally, everybody who is familiar with business administration must be able to explain what the present value of a simple future cash flow in 2 or 3 years is. Naturally, not everybody knows by heart the annuity factor and its reciprocal value. Naturally, but the basic things must be known to everybody. Okay, now this was chapter 9.2, so the investment ideas, my ideas, basics of the basics on that, and I hope you recover well from having watched and listened to that, and I hope to see you soon again. Thanks for watching. If you enjoyed it, share the video with others. If you didn't enjoy it, share it with others. Or if you don't want to share it, call somebody else and motivate them to share it with others. So whatever you do, try to share it. Would be very nice. Thanks. Okay, till next time.